Hello students, next chapter is about equations and inequalities. We will be learning new words related to algebraic expressions, open sentences, equations, linear equations in one variable, inequalities, solving inequalities, and how to use certain phrases related to those topics. Linear equations and two variables. Now the first one is algebraic expressions, and exact topic is translating phrases into algebraic expressions. Now we will understand the word variable. What is variable actually? Suppose any example from real life, and for example, we're 15 years old. In 1 year's time, we will be 15 plus 1. And in 2 years, we will be 15 plus 2, 15 plus 3. And the pattern, you see the pattern is changing, it's growing. There can be any number on x, so we can write it as 15 plus x years old. And x is called a variable here. Let's give a definition for a word variable. A variable is a letter. You see, variable is just a letter that used to represent a numerical quantity. We often use a lowercase letter such as A, B, C for a variable. Any letter, we can write it M, T, N, K, L, and so on. In the example above, x represents a number of years. X is a variable. Now, note that this is not x like in Kazakh language. It's x in English is a variable. And 15 plus x is called an algebraic expression. An algebraic expression is a combination of numbers, variables, operations, and grouping signs. These are algebraic expressions. Let's pronounce these algebraic expressions. X plus 5, 3y, this is not y, it's 3y, 2x plus 5y, negative 3t squared, 5 multiplied by the difference of n and 2, 3ab multiplied by the difference of n and m. Algebraic expressions can contain more than one variable, like in this third example, 2x plus 5y. Now let's learn about statement. An expression is called a statement or proposition sometimes if it contains an assertion which can be assigned as true or false meaningfully. For example for statement, 3 plus 5 equals 8. This is true, right? It's correct. 3 plus 5 is 8. That means it's a true statement. Now, for example, a week contains 8 days. Now, this is not correct. A week contains 7 days, actually. So this is a false statement. 7 is greater than 9. It's also a false statement. The sentence is like, is this a pen? The volume of a cube is negative. These are not statements. There is no assertion and not meaningful. They're not meaningful. Now, what about equation? An equation is a statement which contains an equality symbol between two expressions. Equality symbol is horizontally straight lines, two straight lines. For example for an equation, 2x plus 7 equals 11. This is an equation. And the expression 2x plus 7 is on the left-hand side and 11 is on the right-hand side of the equation. So there is two sides, left-hand side, right-hand side. Illustration for an equation, we have coefficient, variable, or unknown, left-hand side, right-hand side of the equation. In some problems, there might be no solution. We could end up like 5 equals 12. That's not true, that's false. So what will be our answer then? It will be empty set or no answer, no solution. The solution set of an equation is called the empty set, when none of the numbers from the replacement set satisfy the equation. We write empty set to mean the empty set, just a wavy brackets with nothing inside. Now let's answer to some questions. Which of the following expressions are statements? If the expression is a statement, determine whether it is true or false. Let's look at the first one. 4 is an even number. Is 4 an even number? Yes, it is. How do we find it? 4 is divisible by 4, 2, and 1. It is divisible by more than just 2 numbers. So yes, it is an even number. But is it a statement? Yes, it is a statement. It can be correct or incorrect. But in our case, 4 is an even number is correct statement. It's true statement. What about the second one? In any right triangle, the sum of the squares of legs is equal to the square of the hypotenuse. This reminds us a theorem called a Pythagoras theorem. A squared plus b squared equals c squared. Now this is true. This is a true statement. Third one, 3 squared minus 2 squared equals 5. That is 9 minus 4 is 5. It's true. True statement. 3 plus 5 is 9. No, this is false statement. 3 plus 5 equals 8. 5x minus 7. This is not a statement. This is an expression, algebraic expression, with one variable x. X is greater than 5. This is also this is also an expression. 11 is less than 10. This is false, but yes is a statement. False statement. Write the left-hand side of the equation. 3x plus 5 equals 8. Left-hand side of the equation is 3x plus 5. Write the right-hand side of the equation. 3 equals 7x minus 1. The right-hand side of this equation is 7x minus 1. Now, what is a linear equation? A linear equation in one unknown is an equation that can be written in the form ax plus b equals 0, where a and b are real numbers, a is not equal to 0, and x is a variable. 3x plus 2 equals 0 is a linear equation, because here a and b are real numbers, 3 and 2, and a is not equal to 0, which is 3 is not equal to 0. Let's explain this, solving this equation to x minus 5 equals 0. How do we solve it? We need to isolate the variable x on one side of the equation. Now the original equation is 2x minus 5 equals 0. In order to get rid of 5, we add 5 to both sides. Second operation, 2x minus 5 plus 5 equals 0 plus 5. Nothing changes here, we just add 5 to both sides. The next operation is we simplify both sides, that is reducing 5. Minus 5 plus 5 gives us 0. So it will be 2x equals 5. The next step is we divide both sides by 2. Dividing, subtracting, adding, multiplying both sides of equation by some number cannot change the original equation. So it will be 2x divided by 2 equals 5 divided by 2. Now here we can find x by proportion. x is equal to 5 over 2. The answer will be 5 over 2, but this is an improper fraction, as we said in previous lesson. So we can convert it to mixed fraction, and it will be 2.5, or 2, 1 over 2. The next important step is combining like terms. What is like terms? We use this word a lot when explaining problems. Terms of an expression which have the same variables and the same exponents are called like terms. To combine like terms, we add or subtract their numerical coefficients and keep the same variables with the same exponents. For example, in this situation, 14x over 14, now we're simplifying like terms, which is 14. And for example, in this next problem, negative 2x plus 6x, these two terms are called like terms. We can add them or subtract them. For example, in this situation, we can add negative 2 to 6 and we get 4x. And we also do collect variables on the same side of an equation. When doing that, it is best to choose the side which has the greatest coefficient of the variable. For example, in 5x minus 13 equals negative x plus 1, we collect the variables on this side of the equation. Now the largest coefficient of x is 5 here, so we collect variables on this side. That means on the left-hand side of the equation. In some problems, there might be a contradiction, an equation which is not true for any possible value of the variables. It contains it called a contradiction or impossible equation. For example, in this problem, we can get 1 equals 5, which is not true, false. So this equation is an impossible equation. 1 cannot be equal to 5, so it means it is a contradiction. We also got negative 13 equals 8, which is false, so this is called a contradiction. Let's talk about inequalities. Definition of inequality. A statement which contains an inequality symbol between two algebraic expressions is called an inequality. There are 5 types of inequality. We use a different inequality symbol for each type. Now here you can see 5 phrases that we use when talking about inequality. First symbol means is greater than. Second is greater than or equal to. Third is less than. Fourth symbol means is less than or equal to. The last symbol means is not equal to. For example, 4 is greater than or equal to 3. Now I'm going to solve this first inequality here. X plus 3 is less than 5. The next thing that I'm going to do is moving 3 on the right hand of the inequality. So x is less than 5 minus 3. 5 minus 3 gives us 2, so x will be less than 2. Let's try to explain example number 1.48. The original inequality is negative 2 less than or equal to 2 minus 4x over 3 less than or equal to 6 over real numbers. How are we going to solve it? To get rid of 3, we multiply each side by 3 to remove the denominator. And now, when multiplying both sides by 3, we reduce 3 in the middle. We're simplifying like terms. So we got rid of 3, and now we got negative 6 is less than or equal to 2 minus 4x is less than or equal 18. Now we continue to simplifying. In the middle we have 2. 2 minus 4x. Now we have to subtract 2 from both sides. That is negative 6 minus 2, 18 minus 2. It gives us minus 8 is less than or equal minus 4x is less than or equal 18. Now we have to get rid of negative 4 again. And in order to do that, we divide both sides by negative 4. All sides by negative 4 actually. So we got negative 8 over negative 4 gives us 2. 2 is greater than or equal x is greater than or equal negative 4. We might be thinking why less than or equal has changed to greater than or equal. By rule of inequality, when dividing to negative number, our signs change. So it will be negative 4 is less than or equal x is less than or equal 2. When drawing on the number line our inequality, we find 2 and negative 4 or number line. First is negative 4 and then will be 2, closer to 0, positive number. So the solution set is any number between negative 4 and 2.